My name is Faustin. I am from Hamanaz Laboratory at Gunma University, and we are working on GSOL, a tool that uses the second order laboratory, SOL, to check the confluence of Haskell rewrite rules. SOL can verify the confluence of higher order rewrite systems, and GSC has the feature of user-defined rewrite rules. To motivate GSOL, let's consider this sample program with two rewrite rules, F0 and F1. The rules have the same left-hand side, fx, but F0 rewrites it to the literal 0 and F1 to the literal 1. We also have the expression F99 from which the variable e gets its value, and F99 matches both rules. But from the specification of GSC, we don't know which rule is going to be applied. Depending on the rule that is applied, F99 is going to be rewritten to either 0 or 1. 0 and 1 are different literals, and they are already in normal form. This makes the two rules in this program non-confluent. But GSC does not notice this non-confluence. So we are developing GSOL to help with automatically check the confluence of the user-defined rewrite rules in a Haskell program. But why is confluence important? Confluence is the property of a rewrite relation that says that all divergent computation paths are joinable. And confluence guarantees uniqueness of normal forms, which is particularly important in functional programming. GSOL uses Newman's lemma to conclude confluence by checking local confluence and termination. And local confluence is a weaker variant of confluence, which requires that only all one-step divergences be joinable. And termination is the property of a rewrite relation with no infinite rewrite steps. We implemented GSOL as a GSC core plugin, so it works on GSC core programs. And GSOL first collects the GSC core rules, then it converts the core rules to SOL computation rules, and calls SOL for the verification. Then SOL performs its checking functions and prints the results to standard output. So GSOL uses SOL for checking, and SOL is an implementation of a formal framework of second-order computation systems. It has its internal language of metaterms, and metaterms are made of variables, abstractions, function terms, and meta-application. The metaterms have up to second-order types, and pairs of metaterms form computation rules in SOL. GSOL can be used from the command line. The command takes two parameters, the property to check and the path to the Haskell program file. The property is either CRI for checking local confluence and SN for termination. CRI is short for a critical pair, and SN is short for strong normalization. So the property is optional, and if it's missing, then GSOL will check both local confluence and termination. There is also a web interface, which is available at this address with some examples. We experimented on the Arrow library of GSC, and the library Arrow provides a way to programming with various computational effects in Haskell, and it is implemented with the type class of the same name, Arrow. And the library has defined several rewrite rules, which assume that the Arrow is the function constructor. And when we run GSOL on the library, it reported 8 critical pairs, such as this one, between the rules, generated by the rules compose first and first arrow. So from the output of GSOL, we read that the sub-expression first f from the left-hand side of the first rule is unifiable with the entire left-hand side of the second rule by this unifier. And the result of unification is this expression that can be rewritten with either rules. And the result of rewriting is these two expressions that are in normal forms, that are different and are in normal form. And so the rules in the library are not confluent. This is useful information to improve the design of the rules. So we are still developing GSOL, and as a future work, we want to improve the handling of types when translating from GSE core rules to SOL rules. For now, GSOL drops type constraints, and we know that this is fine for checking critical pairs, local confluence, but it makes termination checking weaker. To summarize, GSOL is a tool that checks the confluence of Haskell rewrite rules using the second order laboratory, SOL, and GSOL checks confluence by checking termination and local confluence. We have a web interface for GSOL available at this address, and there we can find the example for the arrow library from the pull-down menu, and we can visualize the results by ensuring that the GSE rules format is selected and the option WCR. WCR is short for week or weekly church roster. It's also a synonym for local confluence. And so when you submit the program, GSOL checks and returns the results. So these are the 8 critical pairs, and the conclusion is on the last line. So some details of GSOL, are described in the draft paper available at this address. If you're interested in GSOL, please refer to the draft or contact us. Thank you.